part of being a CAD CAM programmer is to understand how you're going to program this part using CAD and CAM software. Then you're going to need to understand the posting system. The post takes generic code from a CAD CAM system. It's generic because it doesn't know what machine you're going to, a Haas, Herco, or a FANUC control. It doesn't know. So you need what's called a post processor to take this generic code and post it to a specific machine. And so that's an important process. In order to do CAD CAM, you really need to you have to know CAD, you have to know CAM, and you also have to have a processor which takes, again, the generic code and converts it to a specific code for a specific machine's control. So that's the general process. You need to know those three things. Also, you need to know about clamping, orientation. You have to understand that when you see a print, and the print has the X, Y in this corner, and the Z is the top of stock, for example, you know, that's fine on the CAD system and on the CAM system. But you have to take this in the physical world, you know, and connect from the virtual world to the real world, and you have to orientate it on a mill or a lathe or whatever you're doing. So you have to be able to coordinate this with the CNC operator. That might be a different person, or it might be you. Either way, you have to actually take the physical stock, rough stock, and it's called fixturing. Hold it down. As you know, if you place this flat block on a table, it will sit flat. Okay, there's a plane there, keeps it from going up or keeps it from going down, but it can still turn, it can still rotate, it can lift up. So we have to constrain those movements. So for example, if I put a little wedge, a block of material here, then it can't go any further and it keeps it lined up. So we have a 3-2-1 alignment. 3 points means a plane. 2 points on a side, an edge, will keep it from sliding back and forth, and a 1 point will keep it from moving. So if I do a 3 point, a 2 point on this front edge here, and then a single point here, then my block is captured in the corner. Now what it can do is lift up and push away from the corner. So we'd have to constrain that by either clamping it or holding it down with clamps on top, some other ideas. In our case, we're going to use a vise. My whole point to all this is that you have to understand how this is held in place and how you constrain it from moving around while you're milling it. And that layout needs to be included into your camming process. It needs to be represented, and you need to mark it for your tool paths not to hit those clamping devices or those fixturing devices. So watch this a few times until you get a feel for it.